Okay, so last video we talked about ionization energy, which is the amount of energy that's required to remove a mole of electrons from a mole of gaseous atoms. Now we're going to take a look at something called electron affinity, which is the amount of energy when we gain electrons. So the energy change when 1 mole of electrons is added to 1 mole of gaseous atoms. The IB very rarely asks questions about electron affinity, but you do need to know the definition, general trend, and explanation. So as we go across a period, the electron affinity increases. Now, electron affinity is a little bit weird because it increases, and what we mean by increasing is that it gets more negative. More energy is being released as we go across a period. As we go down a group, generally, although there are some exceptions, the electron affinity decreases. So let's take a look a little bit at why. So across a period, my elements are more likely to be filling their outermost shell. And remember from your IGCSE science, as you get closer and closer to the electron configuration of a noble gas, we get more stable. And so our magnitude of our electron configuration increases. Electron affinity increases, which really means it gets more negative. More energy is being released because we are now more stable. Down a group is a little bit murkier. Down a group, but what generally happens is the amount of energy released is lower because my electrons are further away from the nucleus, and so the attraction is much less, and so the release of energy is much less. So again, the electron affinity decreases, which means it gets more positive. Okay, you don't need to know the explanations for electron affinity. I've never seen a question on that, but you do need to know what happens across a period, what happens down a group generally, and the definition.